Okay, I'm starting the Scala from the very scratch. Okay, from the installation. Okay, and then the Scala features and how to use Scala. And the main purpose of the Scala is to learn use in the Spark. Okay, I will come on that point. Okay. So if you have not installed the Scala, so how can you install Scala in your Windows or Ubuntu, anywhere you can do. Okay. First, I tell the how to download the Scala and how to install and configure. Okay. So Scala, you can go to the Scala download, the official website of the Scala. So the latest version release is the 2.13, and even you can do the 2.12 also. Okay, so you go here and Scala we can download Scala zip. Okay, and Linux we can download the tar file and then we can unzip it, and we have to set the home path. Okay, so that's a way to configure and install the Scala. Okay, so here if you see, like okay, for their MSI is also there. Through this you can also install. Okay, that is a one way. And in the Windows, like you can download the tar file and this tar file, and you can unzip and then you can set the home path. Okay. I'm expecting it. Scala mostly follows the Java. Okay, it's all the object-oriented functional programming. All concepts are covered as the same Java because it runs in the JVM. Okay, so it has on compiler. Scala has on compiler, Scala compiler, but it runs in the JVM. Okay, Java runtime environment. Okay, Java virtual machine. So Java and Scala both are having the same runtime environment. So once you extract this, you can copy. I'm just copying in some location. Okay, so this path I will set it my home path. This is a command line, and I will show that how to use in the IntelliJ IDEA. Okay, so we can use the IDE tool. So IDE tool is more easy to work. Okay, because command line tool is interactive shell, same like a Python has also the command line tool. So interactive tool means like when you are giving some command, you will get immediate output. So line by line statement you can run in the Scala, same like you run in the Python shell. So we can run in the Scala shell. So this is a command line shell I'm configuring. And if we want to use in the IDE, some IntelliJ IDE, so I will show that how to use in the IDE. We have to add the plugin. Okay. So I have to go to one environment variable and I have to set it home. And path, I have to set the bin path. Okay, I will open CMD. Okay, because Java is not installed. Wait. Reset the page. I'm just resetting the password. And how can you download the IntelliJ? Parallelly, I tell that also. IntelliJ, you can go to the IntelliJ idea website, JetPrint. Okay, so you can download IntelliJ. So you can download this community version. Okay, if you are using the Windows. Okay, so if you have other operating system, you can download the other one. Okay, tar file you can download. Okay, I will show you how to open in the Ubuntu. Okay, IntelliJ. So I have already installed. So you just download and install it IntelliJ. So IntelliJ, we have to add a plugin for the Scala. Okay. So initially, when you will not get to run Scala directly, so you have to go to File menu and go to the settings. And here, go to the plugin. I have already installed Scala. If you search here Scala, so you will get the Scala plugin. So this Scala plugin you have to install, and then after restart the IntelliJ, then you will be able to get the, you will able to create the project for the, you can use the Scala SDK. Okay, so I will show how to create a project here for the Scala. Okay, and how to use in the Java. This time. Okay, let's start first. Basic introduction of the Scala. Okay. Okay, I prepared this notes from the one website, Java T Point. You guys can also refer from Java T Point. Java T Point is a website. From there, I refer this on notes. Okay, so here you can follow the complete Scala tutorial. Okay, so Scala basic features, functions, OOPS concept, and Scala collection, exception handling. Okay, so these are all concepts. This is a complete Scala tutorial. So once you learn this Scala tutorial, then you can easily understand the Spark Scala API. Okay, when you are writing the code in the Spark with Scala, we can have a different flavors are there. We can write in the, even the Spark with Java, Spark with Scala, Spark with Python. Okay, so there are the different languages are there for the Spark. Okay, so Spark is itself is written in the Scala. Spark is written in Scala. Okay, so why we say like which language is good for the Spark? Okay, so it depends the scenario. If I say my application is not using any machine learning and data science algorithm, okay, my application is needed for like faster performance is very important for my application. So the Scala is the first choice for running a Spark application, okay, because Scala is a native, okay, and the native, so your code will be faster, compile and run, and the performance will be good as compared to other, okay. And if we go like for the some machine learning application is there, okay. So suppose my requirement is machine learning data science. Okay, so I should go PySpark. So this is a choice generally we should do based on the, because if I'm using the PySpark, so I will be use efficiently Python, and Python have the machine learning algorithm support. So I can easily use that, and I can write the application for data science machine learning algorithm. Okay. So how to start the Scala? Okay, so Scala first, if you want to learn Scala, we have to like first make an environment, right? I have to set up either IntelliJ I can use, or I can use command line tool. Okay, so command line tool, when I'm using a Scala command line tool, so when we use command line tool and when we are using IntelliJ, okay. Suppose I have to just do testing, I have to do testing. So I have to do testing. So I can go for Scala command line tool because I want to do interactive shell. I want to run each command one by one, and I want to get the result. So for testing purpose, Scala command line tool is good that you can test immediately. But when you are deploying your application, right, you want to create a application jar and you want to do Spark submit. So when you want to run application on the cluster, right, so then we go for Scala, we can go IntelliJ. Okay, IntelliJ ID, IntelliJ ID. Here I can write application, right? Scala application, and for Spark, I will create a jar. I will create a jar of application and deploy jar on Spark cluster. Okay, so this is the way. Scala not only used for Spark, okay. I'll tell you the Scala use cases, okay. So like we know that Java has a multiple use cases, right? Java is used for the web application, okay. Web applications we use like Spring Boot applications, right? We create using the Java, right? Java can be used multi-threaded applications. So Java has multiple use cases. Java can be used with the Spark also. Java with the Spark, like data analytics also we can use the Java. Okay. Similar way, Scala also can be used in the web application also. Okay. So like we know Python has a combination with Django, right? We already know about Django. So Django has the combination. Whatever it is. So Django combination is a web application. Okay. So web application where we have a user interface, we are having a forms and we are submitting form, and backend we have a database. So that web application we use a combination of Python with Django. And Scala has a Play framework. Play. Play is a UI framework. Okay. UI framework. APIs. Okay. So Scala plus Play. Okay. So backend is a Scala language. This is a backend. Okay. Backend is a Scala language, and Play is a front end. Front end. Okay. If I say in the Java, right? Java backend is a Java. Okay. Java is a backend. Okay. And what is a front end here? The React and Angular. Okay. React and Angular. Okay. So here is a front end. Okay. Same thing like Python is here, backend. Python is the backend. Okay. But what is the Django? Django is the front end. So we can write a HTML, CSS code. So that means HTML. So here everywhere HTML, CSS, JavaScript will come in the Angular, React, Play. Okay. So this kind of applications like we can do in Scala as well. But Scala main use is the data analytics. Data analytics. And main purpose of the Scala we use in the Spark with Scala. Okay. So when I install the Spark, I will get the Scala shell. I will get the shell like this when I use Spark with Scala, or when I'm installing the Scala only. When I install Scala and run the Scala shell, running Scala shell, so I will get this prompt. Same prompt I will get. Okay. So how will you differentiate this prompt or this prompt? So here you can use Spark and Scala both. Spark and Scala APIs we can use. We can use both. Okay. But here this is a only Scala, running only Scala. So here Spark will not allow. Only Scala code, Scala API code you can write. Okay. So it's an interactive shell. Okay, same Python you have experience, so you can get it immediate result. Okay, whatever statement you run. Okay. Okay, so far is clear. Okay, so how to write a Scala program, right? Okay, Scala has the class and object. Two things are there. Okay, so object in Scala is a singleton, right? Basically, we know, right? Every programming has the main function, right? We have a class and we define main function. Whether we use Python, Java, or any programming language, every programming language has the main function. We define main function in the class. Okay. But here the main function is defined in object. So object is called here in Scala is singleton. It's a entry point of your execution. So how will your execution will start? It will start from your main function, and that should be defined in a main object, the object. So object is one type of class. Okay. So even we write functions in the class, but we cannot execute main function. Like we cannot write like class, my class, and then you say, here you define main function. This will not work. Okay. Because they have given the design such a way, only object you can define the main function and you can run your object. Okay. But suppose everything you cannot write in a one single object, right? You have to write some classes and define the functions. So what they say, you define class and there you define the functions. I will show that how to write the syntax of the function because it little change. Okay, so from the Java. So when you write a function, so you write def show, and this is my function. Okay, and this function I want to use it here. I will create a instance of the class. So here, so instance and object both are interchangeable term, right? Okay. So one object definition is it's a similar to the class. It's like a prototype. Object is like a prototype where you define main function for the starting of the execution. Okay. That object is a one type of object. Another type of object we call it, suppose this my class, I define the variable. I say variable I did my object, okay, equal to new, and then I say my class. If I write like this you can call it as a instance or object, both are same. Okay, but this object or object is mean, right, you are creating a one instance that will be allowing to create, that will be allowing to the call your functions and properties, you can use it. Okay, so generally the way is like you will be defining any number of classes, and those classes you will be calling from the main object, and this this object whatever name you give, this you will do run, this you will run, right? This you will run, either you are using for the Spark, you will use a Spark submit this class. Okay, so Spark submit, there is a command for running any main function object. Okay, you can run it. Okay, so that will come in the Spark basically, but here I'm talking about how to write object. Okay, so define the object is a keyword and give the object name, and then you define the main function, and there you can write your function body. Okay, main function body, and your execution will be starting from here. Okay, so where to use Scala? So I have already talked about like web applications, some libraries, and Akka is the one multi-threading framework is given by the Scala. Okay, suppose I want to write multi-threading. Multi-threading is separately there, like a similar to the Java. Scala also support multi-threading. But other than the multi-threading, like there is a separate framework is there for streaming with Akka. So Akka framework is there. Okay. Batch processing we can do, concurrency application, right, where the concurrent requests are coming. like a distributed application where the multiple concurrent requests are coming. So that kind of applications we can do. And data analysis with Spark, that I already talked about, right? Spark is a very good fit for the Scala, because Spark native language is a Scala. Okay, so Spark is written in Scala. Okay, so that's the reason the Spark with the Scala application will be much faster than the other languages application in Spark. Okay, history of the Scala. Okay, Scala is started. Anybody's asking anything? Okay. So Scala is starting in the 2001, and 2004 is initially released, and this is the guy Martin who started the Scala. Okay, so this is just all about introduction things. So, okay, Scala is a pure object-oriented programming language because it has functional programming and object-oriented programming, both are there, similar to Java. Java introduced functional programming from the Java 8. If you know the earlier version of Java, there was no functional programming, there was no Lambda, but Scala has given the functional programming from the beginning. Okay, so you can say the Scala functional programming is very, very old. Okay, and these are the features why the Scala is much popular, right? Why the Scala is popular? Because it's a kind of scripting language, like same Python. We have to write a very, very less code. Okay, like in the Java, I define a complete main function and I have to write a code. Okay, here I can use a simple print statement. I can run my Scala code. Okay, on the shell, Scala shell I can run. Okay, so first feature of the Scala is type inference. So you know Java is a very strict type language. Okay, so when you are defining in the Java, okay, so when I define in the Java, so Java we define the data type first, right? I say int x equal to 10. So here, you know, in the Java, it's mandatory, right? If I don't define this type, I don't say this int, it will not accept, right? It will give the compilation error. But in Scala, we can define like where x equal to 10. Okay, so it will automatically take the type 10 is an integer value because it will understand this is the type. Same like in Python, you know, you just type in Python x equal to 10. So Python accept this value, right? Because it understands this is an integer value. If you are giving a string value hello, okay, so it will take it as a string because it's a double quote string, right? So this is called type inference. So Scala is a type inference, Python is a type inference is there, but in Java is not. Okay, Java we have to strictly define the type. Okay, I will tell about what is this where and val. Okay, these are the two keyword are there. We have to use when left side when I'm defining any variable or object, I have to define either where or val. Okay, so what is a singleton object? Singleton object is in Scala is like a object. Object is a singleton, right? I already discussed here. The object is a singleton. So when I define any object that is singleton because it's an entry point and it starts the execution. So that is the reason it is called singleton. In the Java, singleton is a pattern. Singleton is a class, right? We define the private constructor and a static instance variable. If somebody knows in Java, so singleton is an static keyword we use to define a singleton. So singleton means only one and one object will be created. Okay, you cannot create a multiple copy of that object, and that will be your entry point. Okay, so the reason is like same object I will not create multiple times, right? So it will consume more memory. So that is the reason singleton is preferred. Okay, so here is no static keyword in Scala. We use this object as a singleton here. Okay, so any property and function you want to call in Scala directly, you can use class the object name dot you can do. Suppose I define this show function in my object. How to call this? I will simply say main object dot show. Main object dot show. Suppose I want to call my main function. I will say dot main and I will pass the null here. Okay, because it is taking a parameter argument string args. So I can call like this. So it's like a same in Java also the static method, like we can call it like this way. Okay. So next thing is the immutability. So here is a Java Scala is having an immutability concept. Okay, so there are the two types of keyword we use. Like one is a val and var. Okay, val is immutable and var is val is immutable and var is immutable. Okay, and I will explain it val and var. Okay, lazy computation. So Scala by default is supporting lazy computation, and the same feature is there in the Spark. Spark with Scala is a lazy. So what is the mean of lazy? Lazy means the immediately the computation will not be done. Computation will be done on demand when it is needed. Okay, so that is called lazy computation. So what is the advantage of the lazy computation? Right, because when I'm calling some action, then all the transformation will trigger. That's a concept in Spark, right? Similar way, lazy evaluation is there in Scala. So when we are doing any operation, it will not do immediately. Okay, when I'm calling an action, then it will perform the transformation, all the functions. Okay. So Scala evaluate expression only when they are required. Okay, so it will occupy the space in memory when it is executed. Okay, so it will be used for the increasing the performance. And another concept is there in Scala is case classes. Okay, there are the various type of classes are there, not only simple class or object. Okay, there is a case class is there. There is a companion class is there. So implicit classes are there. So there are the various type of class types are there. Okay, so case classes are used to define simple, like I want to define only properties. So simply I create a case class, I say my class, and then I can define id is the integer type, name is a string type. Like I can simply define this is class, my class is written. I want to use this class, I want to create an instance of this class where x equal to, I don't need to use new operator for my case class. I can simply say like this 2 comma xyz. So I can create an instance of my class. I can create an instance of my class. I can create an instance of my class, and this instance I can use, I can print the value. Okay, so I can say x.id, x.id and x.names. I can print it. So once this is a common way, like generally we create an instance and then we can use the instance and we can call the values of the instance. So first we have to set the values. So here I have set the values, right? By calling the class, this constructor, right? That is class name as it is I'm using here, and I'm just setting the value and I'm getting the value here. So I can do the print statement. Okay. So the main use of the case class is in the pattern matching. Case classes are used like when I want to create a different case class and I want to compare it in the switch case, right? I want to identify, okay, if this is the case class instance is coming, so I have to do this operation. And if I want to do this operation, I should use this case class object. So I define the multiple cases. So those cases I will define in the pattern matching. Okay. I will show the example of the pattern matching. Okay. Concurrency control. So we can use, I told Akka framework is there. That is a very good support of Akka. And there is a actor model. So this is completely a separate APIs is there. Okay. String interpolation. Like I want to write a println statement. You've seen in Python also, like we use an interpolation. Okay, similar thing is here. Like I want to print the decimal values, integer values, okay, string values. So I can use this interpolation strings SF. Okay, so I can use it. Higher order function. It is very important, right? The function is a passing as a parameter and function is written as a parameter. That is called higher order function. Higher order function is concept in every programming language is there. Mostly the functional programming having the higher order function. So higher order function is as a function you are passing as a parameter, and that function which you are passing as a parameter you can call in your inside another function. So that's the purpose of passing as a function as a parameter. Okay. So if you know about the map, flat map, filter in the Spark, okay, in the Scala also these functions are there. Map, flat map, filter, these are all higher order function. These are inbuilt higher order function. Higher order function. These are inbuilt higher order function. In the Python, if you know about the decorator, decorator is basically the higher order function. So you can decorate, right? You can passing a function as a parameter and you can you can use that function in another function, right? So decorator is in the Python is the pattern, right? There we can use same function, map, flat map, filter. In Python also, these are the higher order function. So these are inbuilt higher order function, but I can create my custom higher order function. I can create, okay? I can create my custom higher order function also, okay? Trait is a similar to the abstract class in Java, okay? And abstract class concept in Scala also there, but trait is an additional partial implementation, right? Like you can define the methods like abstract as well as non-abstract method. You know, abstract class has both, either abstract or non-abstract method, both. So generally, when I'm extending any abstract class, I have to override those abstract method. Otherwise, I have to make it that class also abstract. And trait has the one more advantage over the abstract class. Like in the Java, multiple inheritance is not there, right? Through interface, you can have a multiple inheritance, but not classes, because you cannot extend two classes in Java. But trait is giving a benefit, like you can extend one trait. Like suppose I have a one class in Scala, okay? Class, my class, and I can use one trait, extends trait one, okay, with trait two. So two traits I can use in a one class, okay? But you cannot extend two classes, even Scala or Java, both you cannot do, okay? So trait is giving a benefit over the abstract class. Abstract class is also there, but trait is giving one more extra benefit, like you can extend one trait and you can use another trait using with clause, okay? So generally the problem comes, right? I have to go with the interfaces in Java, because that multiple inheritance I have to do with the interfaces, because one class can implement two interfaces, but not two classes, okay? So rich set of collections. So collection API is there. We know collection is like a set of values we can contain in a variable, right? That is called collection. If I say list, set, map, tuple, okay, so these are all collections, okay? So it will come in the collection. So here is some extra collections are there, like sequence is there, bitmap is there, bit set is there, list set is there. So these are extra functionality, like they have given this set of the collection APIs they're giving, okay? So this is so far Scala features. Now I'm starting the core programming, right? How to start the coding, right? The coding is an important part in the any programming language, right? So first of all, we need to understand the basic fundamentals of any programming language, okay? So we know programming has some basic building blocks, right? So we know basic building blocks. What are the basic building blocks, right? We say operators are there. So there are the different types of operators. We already know about those operators, right? Arithmetic operator, relation operator, right? Logical operators. So operators are there, relation operators like greater than, less than, right? So these operators are there. Other than the operators, we need functions. We have functions also there, classes are there, and we have to understand these other concepts also, traits and those things. So these are the, and I say like a data type. Data type is very important, okay? Data types, okay? So we should know how many data types are supported. So Scala supports same like a Java data type, but here everything is object, okay? But Java support primitive and object both, but Scala support only object. So if I say int, so int is a object type. If I say string, this is also object type. I have a boolean, this is also object type, okay? And I have a double. So this is this, okay, double and float. These two are for the decimal points. Integer, long, short, these are for the like a whole number, and boolean is for and the char. So these are the all data types, okay? So we can define in the Scala, okay? So first is what is a mutable or immutable? This is very important concept, because everything is defined in a Scala either using val or var. Without val or var, you can't define even any single thing, right? You can't create an object, you can't create a variable, you can't do anything. You have to define first var or val. So where you have to use val and where you have to use var. So immutable variable, when you're defining the variable, like you define val data equal to 100, but if you want to reassign the value, you want to change the value, you can't do. So that is called immutable. The immutability concept is there in Java also. Like we can make create our custom immutable classes in Java by using the final variable, final function, final class. There are a lot many ways are there creating a immutable variable and classes in Java. So in Scala also we have the final, everything is there, like final class, final method, final function, final method, final class, and final variable. Okay, but here this val and var, so this val is defining whether you define the value as a val, you cannot change. Okay, if you define any object of val type, you can't change. Okay, but var type, it will not give any problem. Once you define the variable using the var, you can change it and further you can use it. So next time when you will print this data, when you say print data, so you will get 101 value, print data. So you will get the 101. Okay. So in IntelliJ IDEA, like suppose I want to create a new project. Okay. So how to create a new project here? New. So you can create a project. So for Scala, actually Scala, okay, build tool, I tell you first. Okay. So Scala has different build tools. Okay. What is a build tool? Okay. So build tool, like which is compiling your classes, right? Okay. So Java support, Maven and Gradle. Okay. Scala support these two, Maven, Gradle, and SBT. SBT is the extra one which is not in Java. SBT is specially designed for the Scala. Okay, simple build tool. And this SBT is, so we can create either project of Maven based project, Gradle based project, or SBT based project. So either one of these three projects we can do, but we should have the plugin for these. Okay. So if I'm using a Maven plugin, Gradle, or SBT when I want to use it, so I have to install the SBT. Okay. So Maven is very easy one because Maven is by default come with the IntelliJ IDEA. Okay. So when I want to create any Maven project in the ID, so simply I have to choose the Maven, and here I have to select I have to say the project name, Scala project. Okay, so it is Java project is creating. Okay, because Maven is a by default tool for the Java. Okay, even this is also creating a Java project only, but we will change the package. Okay, by default the Java package will come, we will change it to the Scala. Okay, so I will give the here archetype. Archetype is a quick start type. Okay, quick start archetype, and then I will create a project. So either I can use this window or new window. So I can create a project. So this is a Java project. Nothing Scala is here. Okay. So how to add a Scala in this project? So first of all, I have to change the package here. This package I have to change because the hierarchy of the Scala is src main Scala. So I will refactor it. I will refactor to Scala. Okay. And the test package also I will refactor. So there are two main is for the classes, source classes, and test for the test classes. Okay. Here I will also refactor Scala. And once I do refactor, now I will add a framework support. So here is, if you see, add framework support. So if you click on this, you will see here the Scala is option is coming. Okay, so you select Scala, and if this library is not there, so you have to click on the create and click on the download the first time when you are doing. Okay, and then you have to select the version. 2.13 is the latest version. You can choose other version also, older version. So when you click on OK, so it will download it, and then you can select in the drop down. You can select in the drop down, and once you select in the drop down, from the drop down you select it and then click OK. Now your Scala is added, the Scala 2.13.10 SDK. So Java SDK is needed because I told you the Java runtime environment is needed. And for compilation code, like Scala has the Scala SDK. So this Scala SDK libraries I have to add. How to add? Using the add framework. Okay. Once I add it, and I have to add the plugin also before that. I told about that, like settings. I will go to plugin, and I have to install this Scala plugin. If you don't install this Scala, so you can't see this add framework. This will not come. The add framework, you will not see. You will not see the Scala here. Right now it is gone because I have already added. Okay. So if any project you are creating, any new project you are creating, you will see that Scala framework support. Okay. So once it is created, now you can start writing the Scala object or Scala class you can write. So you have to go to the Scala class, and here are the options. So I told about like case class, object, case object, trait. So what type of class you want to define? So I say I want to define object type. So I just give the name, main object, any name you can give. And once you create this main object, so you will define the main function. So just you type main and control space bar you use. Okay, and then enter. So you will see the main function syntax will come. Okay, so once the syntax will come, you can write print statement. So in Java we have system out.println. We write a very like a this one we write system out.println. But in Scala we don't need to write this much. We can simply write print or println. Print is for the same line to print, and println is the new line. Okay, so this thing is common, println and print. So println use, and we say hello world. And one more thing is, in Scala, no need of semicolon. If you put it semicolon, it is not a problem, but it is not required. Okay. It is not required in the Scala code. Any end of the line statement is not needed semicolon. So when you run, now you can run main object. Okay. Suppose you want to give some parameter, command line parameter, you want to give some dynamic values to the your program, right? So there is you can create application type. So this application is by default there, but there is no parameter is there, no program argument is there. So I want to give some program argument parameter 1, 3. So 3 parameters I am giving. Okay, and I apply. Okay. So how to get those parameters, because these parameters values are coming in args, and this is the array type. So you know, right, whether you pass a one value or more than one value, all values will come in the array. So if you have only one value, so only one value you have, so you can simply do args of 0, args of bracket 0. So here we are not using the square bracket, here we are using round bracket. So this is Scala syntax we are using in array, round bracket. Okay, args of 0. So if I print args of 0, so that is representing the first value. Okay, so this is representing the first value. So if I want to index 1, index 2, I can print it. Okay, so this way I can write a code in the IntelliJ IDEA. Okay, IntelliJ IDEA, I can write a code and then I can execute the code. Okay, so here is a very simple way. Just I define object. If I want to define the class, so I will go right click here and say Scala class and say my class, and class type, I have to choose the class type. And here I define some function def show. I say here some print statement, class show function. Okay, now I want to use this class. So I have to create an instance of this class. Okay, this is all object oriented part. Okay, so here I have to create a, so I will define a val or var type. Val, I say obj equal to, I say my class. New keyword I have to use always because it's not a case class. Okay, and then obj dot So now I will run. So this is always I will run object only. I will not run the class. Now I can get whatever I defined in the class, I can call it here and I can print. Okay. Okay. So this is the concept. Okay. I was talking about this one. Okay. So suppose if I write like this, how it will. So I'm defining a where type. It's not giving any problem. Okay. I'm running it. 101 is printing, right? Because print ln 101 is printing, right? When I use the same thing with the val, I define using the val and I say data one. And I say here data one and data one. I'm getting a error itself here, reassignment to val, because it is not allowing to me to change the value. Okay, so that is basically val. So you should use either var for the modification or always define val for only as a constant. You cannot change it. Okay, so we cannot change it. Okay, so this is the concept of val and var. Okay, so data types I've already told about boolean, byte, short, char, int, long. All these are the same data type in the Java one, and same types are here. Okay, so conditional statement. Okay, now we are coming to the expressions, right? Like we have to write if else conditions, for loop. Okay, so scala, how to define the conditions? It's the same like braces we use, right, for defining more than one statement. If one statement is there, we don't need defined braces. Okay, for single statement we can write without braces. So this is like some variable value is there and I want to check whether age is greater than 18, so it will print. Okay, so this is simple if else condition. So each and everything I will not run, just I will show you so that we can just quickly grab it and then we can go forward. Age is greater than 18. Okay, so if I make it 17, so it will skip it because the condition will not match and it will not come. So in this scenario, I should use the else part. I should use else and I should print ln. I should say print ln age is less than 80. Okay, so it's simple if else statement, but just you remember, right? You define, but if else condition you are defining similar to the Java one, nothing change here. Okay, if I don't define this type, it is also fine because it's a type inference. That is also fine. So type is not mandatory. Colon type we give. So here is where variable name. If I want to explicitly say this is a string type, okay. So I say this is my string type value. So when I say string type, so it is complaining to you. It is saying to you, you are saying this is a age is a string type, but you are defining integer value. You are giving integer. So it means it's a wrong. So it is asking to change it. Okay. Now again it is complaining here because it is saying here you are comparing with the this age is a 17, you are comparing with the 18. Okay, so you have to int you have to use you have to
phone pay వేసుకున్నాను phone లో
so you have to change into integer. Even the value is string, but actual content of the value is integer value only. Okay, so you have to int. So when you make it this, it is now not complaining, right? Now it will work fine because the 17 you given as a string, but it is converted to int and now it will be going to compare. Now it will work. Okay, age is less than. So sometimes like, okay, the command line parameter always coming as a string input. Don't assume it like it will be integer. If args2, even the value is integer, right? This hello world 3 is coming, but this value is string type. The value is coming string type. So when you want to use this one, so you have to change this to like to int. So when I want to use it here, so I have to use dot to int, then only it will work. So this is a 3, right? So 3 is greater than 18 false, means age is less than 18. Okay, so now you will see Okay, and you can print this ARGS2, ARGS of 2. So ARGS2 you can print. So you can see that age is less than 18, 3. 3 is coming, right? So this is the
నాకు తెలియదు భయ్యా 500 తీసుకున్నాడా
who is waiting.
If you talk, please please mute yourself first.
Okay, so this is a simple if else condition. So further we go, okay, like if and else. Okay, so simple way like if and else we can define. Okay, so here modulo percentage, we know percentage is used for the checking the remainder. Okay, so any variable you check remainder percentage 2. So if you getting the 0 means it's a even number, right? We know the definition, right? And if the value is 21, right, so here remainder will be 1, right? When we do percentage 2 will get the 1. So this is a if else condition, like I want to check whether the number is an even number or odd number, I can check it. Okay, so this kind of logic will check it. So nothing is a scala related in this. It is simply just conditional statement. So how to write your conditional statement? If else if conditions, like you have multiple if conditions are there, right? So if else if generally, like if I want to get a grade, right? So I have a 85. I want to check whether it's between 0 to 50, it's a 50 to 60, and 60 to 70. So where is a greater equal means this 50 will be included. Where is a only greater is there, or less than equal, less than only, so it means it's not included. Okay, so when I say the value is 85, so 85 will be lying here in this, so it will print the A grade. Okay, if the value is not matching anywhere, so it is showing last, else is a invalid. Okay, so this is like if else if is else if condition. What is the alternate for this one? Also one is a switch case is there, like we can use case. So I can find the value and I can call the case. And ternary operator is there. Ternary operator is here in the Java also ternary operator. If condition is true, the first value will come. If condition is false, the second value will come. So what you writing if else condition, that if else condition you can write in a single statement. Okay. So rather than writing in a multiple statement, you are writing using the ternary operator way, right? So you are simply defining here, like if the value is greater than 0, then it will print the first value, otherwise else second value, and the value will be assigned to, value will be returned from this function. This is a function. So this function is taking some input value, and based on the input value, it will be deciding the first value or second value. That value will be returned to the result. Okay, pattern matching. Okay, so pattern matching I told about, it's a Scala feature. Okay, like using the, we use the switch case programming, right, in other programming languages. So here is a match cases are there. Suppose my variable a is 1 and I'm matching with the variable a with the case 1, case 2, or this is a default. So suppose my value is not matching either 1 or 2, then it will be coming in the default case, and that case it will print, then it, in that case it will print no. Okay, so this is the pattern matching. So pattern matching we can use for a simple variable, or we can use for the object also. Okay, so when I write this statement here and I want to see what the result will be there, so it will be 1 because I'm giving a 1 is input value. Okay, for my pattern matching. So if I want, suppose my cases are a different data type. You know, in Java, we have this switch case we use. So we have to use this case value, same data type. If I'm using integer, so all will be integer only. But here in Scala, very special type is there, that is any. Any means it can accept any data type. Okay, so any data type, it can take any data type or any return type. So here colon means you are returning any different, you are returning the data type value, and here you are passing the bracket, you are passing the parameter. So both are any. So any means, like if you are passing hello, it will accept hello. If you are passing integer value 1, it will accept 1. Okay, so when I define, So this, in this pattern matching, and I want to use it like this. Okay, I can. So I can define my main function. This is my main function body. So in the main function body, I'm calling it here. Okay. So I'm passing hello. So I will get the hello. So this case statement, because here is no return type. That is the reason it is returning empty. Okay. So if I'm not returning anything, I can make it unit type. So this will not come. Okay. So when I'm not returning anything, it is by default unit. Unit is a no return type value. Okay. And Scala, you don't need to use any return keyword. You don't need to write any return keyword. So it will be by default return. Okay. So when I'm just using only one here, integer value. So any is accepting your one. Okay. If you are giving something else, so that is matching with the default case. So no is coming. So then it is coming default case. Okay. So, and the pattern matching we can use for the object. I told, okay, I can create a case class. So I have a different case class, right? I created a one trait, and then I'm extending the trait, and then I'm creating a dog and cat class. So I want to use this dog and cat, right? Which animal is there? So whatever input animal come, okay, if animal input animal is a dog, so it will print this statement. If input element is a cat, so it will print this statement. So here I'm doing the object matching. Here is a variable matching. Here I'm just matching with the variable. Here I'm matching the variable, right? But here is I'm matching the object. Okay. So I can define the object to case class. I'm creating a case class and I'm passing the object of the case class, and that case class object I'm just identifying. Okay. I'm calling the function and passing the instance of the class, object of the class, a particular class like dog class or cat class, and then I'm getting the print statement. So this is the use of, like, we can use for pattern matching for the case classes. Okay. Okay. So case classes, like, simply define using the case class and class name, and you can define the properties with the data type. Okay. Whatever the type of property is there, you can define the property with the type. And how to create an instance of the class, of the case class? Just simply create a val or var and define the class name. You don't need to define new keyword. Okay. And you can directly print the values of the whatever the object is there, instance is there, dot property you can access. Okay. You don't need to write any getter or setter function, right? In the other classes, if you define the same thing in the class, right, you create an object of some other type of classes, regular classes. So you have to define one setter and one getter function. Okay. But here is directly we can set the value and we can directly access the value. Okay. We can directly set the value when you're creating an instance, and we are getting the value while we are accessing through the instance. Okay. We can make a copy also. The copy function is there. So we can create clone copy. So we can do the copy function is there. So these are the case classes features. Okay. And case classes is used in the pattern matching also, this match. Okay. So we can use. So what is a loop, right? So there are different types of loops are there. We are already know about it. Okay. While loop, for loop. So similar loops are inherited same like in other programming languages. It's the same here. So when I say while loop checks the condition first. If the condition matches, then it will be doing the whatever statement you written in the loop, it will be printing those statement or it will be executing. So when I do execution of loop, because this variable is already there. So how many values is printing? 12, 14, 16, 18, 20, because it's checking the value first and then it is it's checking the value first and then it's checking the value and it's checking the condition and then it is allowing to print and this incrementing the value. Okay, so this is the while loop, and do while loop is it's okay. There are the other while loop flavors, like you can do while with the infinite while loop. So you just put the true and then it will keep running. You have to do Control G. Okay, you can do while. Do while is not checking the condition first time. It will print the statement. It will execute all the statement in the do while, and then it will check the condition. This is the main difference between while and do while. Okay, so do while at least once it runs the it runs execute of the statements in the do while and then check the condition. If condition true, then it will go forward, otherwise it will come out. Okay, if you want to use infinite one, so here also we can use while true. For loop, so for loop in the Scala, right, I have some collection objects is there, right, or I say I have 1 to 10 values. So they are the different variations are there in the for loop. Okay, so one is a I and range. Okay, so here I can define any collection name, or I can define 1 to 10 or like values, like, so by default is the increment value is 1. Okay, so A will be assigned here 1, then next time A will be assigned 2, 3, 4 like this, and then it will print. Okay, so here this operator, this less than hyphen sign, that is used as a taking any collection value or any range. Okay, so you can define either range or you can define the collection. So what is the difference between the two and until? This until will not cover 10, but 2 will cover the last value 10. Okay, until is just before then, so it will cover till 9, 1 to 9, but 1 to 10 and 2 we will cover the 1 to 10. Okay, and if you want to do like 1 to 10, you want to loop and you want to check each values is reminder you want to check, and then you want to print. So this condition will be checked. If it is true, then only it will print, otherwise it will not print. So we can write the statement like this also. Okay, okay, so suppose I want to use this for loop for the collection. So how to use the for loop for the collection? So I define some array or list, anything I can define. So I say where, I say arr, okay, I say array type. So I say 2, 3, 4, 5, 6. So this is a one array. I want to print this array values. So I will use the for loop. For I will say some I is the variable which will be assigned from this array, and then I will print ln I. Okay, so this way I can print any. Here I can make it even list, set, anything I can do. Okay, any collection you can take it. So it will print the values 2, 3, 4, 5, 6. So this way I can print the collection value. So this is simple for loop, just printing the values, taking the values from the collection and print each values one by one. Okay, so this is the way to print the values in the collection. Okay, and for loop provides the yield function. Okay, yield is basically a buffer. Okay, suppose I'm running a loop 1 to 10, but I want to store the values of 1. I don't want to immediately assign the value to the result. I want to keep it the value hold till my all values are done. Okay, and finally once my all values are hold, right, then I will assign as a collection. Okay, so it will become a collection. So if you can see, again I'm for loop I'm using to print the values of this result. So what yield is doing, it is for loop is taking one by one each value in A, and then I'm doing yield A. So yield is just basically storing the result in the buffer. Okay, I will tell the example like string reverse. Okay, if you see this string reverse, so here I'm running a loop for I I am starting from the str length -1. From the last, I'm starting my reverse, and I'm saying to 0. This is a 0 index, and this is a length of string. Okay, so I'm saying length -1. So 0 I'm starting. So this character will be length -1. So I'm starting length -1 to 0 by -1. So I'm decrementing 1 by 1. So this is my last character, this is second last character, this is third last character. Like this, I'm going to up to 0 by -1, but I'm holding these values. So first I'm holding which value? Exclamation. Then I'm holding D. So my final output is coming something like this: exclamation, D, L, R, O, W, then space, then question mark, the comma, O, L, L, okay, W, E, H. So like this, my final string will come. So like this, it is giving the result. So finally, I'm making it to string, because these are the all characters. These are coming all characters, and then finally I'm creating a single string value. So I'm doing the MK string. Okay. So this is the easy way like we can do for the string reverse. Okay. There are multiple ways are there to do. Okay. But this is the one way like we can use the yield to hold the each character, and finally I am converting into the string, because it will be giving you array. This will be giving you the array, but I want to convert to the array to the string, so I'm converting as a MK string. So that is converting as a string value. Okay. If I don't do this, it will become a collection. So I have to use this for loop way. I have to do this way. So it will print single character. Okay. So if I run this, so this is a function, this is a function, this is a function. So this is a variable, I'm assigning it, but I can make it in a function. So how to define in the function? So simply I can say gap string reverse, and I will take input as a string, as colon string type. Okay, and this will be returning as a string also, and then I will define the body, and this body I will copy paste it, because I'm taking input. So I will, so here this str will be this, because whatever input I'm taking, that input I'm processing it. Okay, and whatever this reverse, this is the final string, and I will return it. And I told here no need of return keyword. This function, string reverse function, is returning string, right? So just simply write string here, no need of return keyword. Okay, so this is a return only, and when you are writing this, then it will return your string. So when I want to use it, I define this function, and now I want to call this function. So I will go to my main function. Here I will do println. I call this function and pass some string. Okay. So this is printing the reverse of the string. So this string reverse function is called, it is given input as a string, and I'm iterating this string from length -1 to 0 by decrementing -1. If I don't give this, you will get blank. This is the main important thing, because it will not find the direction. If you are saying here you want to go from end to starting, but what is the direction? So it will not be able to decide the direction, and it will not give anything, because default direction is a +1. So what it's trying, it is trying to go forward, but it has to go back, right? So that is the reason you have to give this here. -1 you have to give by -1. If you give +1 also, that is the same, right? So even if you don't give it or you give +1, both are same. Okay. So if you do -2, what will happen? So 2 character, right? 1 character escape. Okay, 1 character will be. Okay, so D R 1 character escape, right? So every second character will be, it will be decrementing. Okay. Okay, so this is already I talked about, right? List I have and how to iterate the list, simple for loop, and I can iterate the list. Okay. And another way of iterating the collection, there is the for each is there. Okay. Here the lambda will come in picture. Okay. So suppose my collection is array, this collection, and this collection I want to iterate array dot for each. Okay. And now I want to take this collection value one by one, x arrow greater than sign. This is the lambda sign. Okay, just remember it in Scala, the lambda sign is equal greater than sign. In Java, lambda sign is the hyphen greater than sign, and the Python is the lambda keyword. Okay, so when I say x equal greater than, and I say x multiply 2. Okay, so I want to do this dot. Okay, I want to do println of this. I say I want to print each value of, so here lambda is saying pick each x and do multiply of 2 and create a new, print it. I'm not assigning it, I'm just printing it. So it will do multiply 2, 4, 6, 8, 4, 6, 8, 10, 12, right? So it is doing multiply of 2. So this for each is action. In the Spark, you will see this is action, and this for each is basically applying on each element of your collection the operation which you define in the lambda. So lambda is here anonymous function. The function is having no name. Okay, and it's a higher order function. So it is, this for each is a higher order function which is taking no name. It's using lambda. Okay. So here, if you see, if you can print like this, for each direct print you can write, or println you can type, but something you want to do some manipulation thing, right? You want to do some manipulation on the value, you can do. Okay. Or suppose you have a multiple statements are there. So you can use the braces. You can use braces, because single statement you can write directly, but more than one statement you cannot write by the, you have to use braces. So when you say first I want to do print and then I want to do something else, so it will be done in the sequence only. I want to say, okay, I say print, I want to print in the same line, and I say print. So x multiply 2, it will do for 2, and then x plus 2. So 2, 2, 4. 4, 4 is coming. Okay, 4, 4 is coming, then 6, 5 is coming, like this is coming. Okay, so when I do this, so I will see both the println statements are coming one by one, right? 4, 4. It's confusing. Okay. And we don't need to save anything because it's auto save. Okay. So you can see here the 4, 4, 6, 5, 8, 6, 10, 7, 12, 8, right? So this operations, right? So it is giving result. Okay, so this is clear, right? How to use the print and how to use the for each. Basically, for each is also iterating. It's like a similar to the for loop. Okay, but we can print and we can we can call as action for each. Okay. So this is by 2 means plus 2 increment. Okay. So if by default is 1, you don't need to give, but if you want to make it 2, 3, then you can use by 2 or by 3. Okay. Break statement, like you want to immediately break, like you want to come to the point and then you want to break, like you want to come out from the loop, right? So there is a break statement similar to Java, Python. So we have a break statement. So when your values are going 1 to 10, right, by 2, so 1, 3, 5, 7. So when it will come to 7, it will break. Okay, and it will come out. Okay. So if it is not I equal to 7, so it will print ln I. So how many values it will print? 1, 3, 5. Because 7 it will break and it will come out. So your result will be, your output will be 1, 3, 5. Okay, but this break should be inside this breakable. Okay, so this is mandatory, this breakable. Okay, so you have to define the breakable loop. Inside this breakable loop, you define your for loop where you have a break condition. Okay, Scala has a different types of comment: single line comment, multi-line comment, and documentation comment. Single line comment is very anywhere you can write just simply double slash. So your line will be, the further part will be the commented, the same line. Okay, and another one is multi-line comment slash star star slash. So suppose I want to comment this part, so just I select it and control shift slash, so it will be commented. Control shift slash, again I press, it will be uncommented by keyboard. Or manually you want to do, you can use slash star and star slash. Okay, so you use slash star star slash. Okay, star slash star. Okay, here you do star slash. So when you do this, it will become commented. Okay, so this is the way of commenting your statement. Okay, and the documentation comment, generally this comment is used at the method level or class level, like you want to define some documentation, so you use the documentation comment. So documentation comment is, the format is like this. Okay, okay, so this is basic fundamental one. So far, any doubt, anything? Because this is only just basic fundamentals one. Okay, next one I will be taking, starting from the functions. Okay. Okay, we start the function. Okay, so function, we know very useful part in any programming language, because function is providing the reusability, right? What is the use of function? So function is providing the reusability. You don't need to write the same piece of code again and again. So suppose you have to write a 10 lines of code 10 times. So you will avoid it. You will write a function for that and you will call the function. So that is a use case of function. Basically, function is providing a reusability. So how to define a function in Scala? So def keyword is there. For any function, you define the def and then function name. And what are the parameters and type of parameters with the colon. If you have multiple parameters, comma separated you will give. And colon, you give the return type of function. Okay, so you've seen that if you are not defining return type, it will automatically take the type of your return value. Okay, so suppose I have a one function and that function, this function is a string returning. Okay, even if I don't give the return type here, it automatically taken, right? Because it is understood this value is string. If I say my value is integer value, now automatically type is changed. If I say my value is 90.00, my value, my return type is changed, right? So it automatically find the type. But if you know the type, okay, suppose I say my type is a string type. Okay, so now it will complain because you are contradicting. You are saying here return is a string, but you are not returning a string. You are returning the double. So you have to make it a string value like this. Then it will be work fine. Okay. So here is the return type of functions you are defined using colon. It's not mandatory. It will be automatically take, but if you define your own type, so you have to return the same type, otherwise it will complain. Okay, so function we create either with the equal sign or without equal. So simply function like define like this I can create, but I have to return something, so I can use equal also, right? Like I can use equal and then braces and then I can define, okay, the function body. So function body you can do if there is no return type, so there is no need of equal. But if I have to, so I have to use equal in that case. Okay, so like this is my function. It is returning the a value, and I'm calling this function. So if any duplicate value, the variable is there, it will give you the error. So when you print this, it is printing 10. So this value 10, it is printing 10. So you can define with the equal. parameterized function, like simply passing the parameter. So you can define if the function is accepting the 2 parameters, so you have to define 2 parameters. If the function is accepting 3 parameters, you define the 3 parameters. Okay. So parameterize means you can pass the parameter to the function. Recursion function. This is very important one, because generally recursive is we use, right, when we want to call function itself. Okay. The main use of recursion is like when you have to call function multiple time itself and then do the same action again and again. Okay, then you use the recursive. But we be careful, like we should know the proper condition to terminate, otherwise your function will never terminate. Recursive function keep calling. So if I'm going to create this function is a recursive function, so I'm giving a one condition here, b equal 0. So initially I'm giving a value a 15 and b value I'm giving 2. So this condition will not be true. So it will come here and it will call the function example again with the value a is 15 and value b is 1, because 2 minus 1 is 1. Second time also it will not false, and your result will be 15 plus 15, and then you will call second time you will call 15 comma 0. Now this time the condition will be true and you will come out from the loop. You can come out from the this recursive function. So your final result will be 15 plus 15, 30. Okay. So first I'm creating this function. So I'm defining one and I'm calling this recursive function. So when I run this, so how is 30 is coming? 15 plus 15 comma 1. Then again second time 15 plus 15, and then it is calling 15 comma 0, and then it is coming out, right? So it will not perform, it will come out from here. So only 15 plus 15. If I change this value 15 to, okay, this value if I change it 3, so now my result should come 45, because 3 times it will do 15 plus 15 plus 15, then it will come out. Okay, so it will take 3 iteration, right? Third iteration it will come out. Okay, so this is, suppose I want to create a similar to this recursive, I want to create my own factorial program, right? So I want to ask you, right, how to write a factorial. So what is the input for the factorial? What is the input? Input for the factorial is 2 values or 1 values? Factorial, nobody knows. Factorial is like 5 factorial is 5 into 4 into 3 into 2 into 1, 120. So factorial of 5 is 5 multiply 4, 5 multiply 4 multiply 3 multiply 2 multiply 1. So that result will come 120. So this is the factorial. So this is the factorial. So factorial will be taking the 5 into 4 into 3 into 2 into 1. So suppose I want to create my own factorial function. So first of all, I should take only one value. Okay. And I should have the return also integer, because I'm taking integer 5 and returning integer also. Okay. And now I will check this a is when my terminate condition. What is my terminate condition? So when my values is decreasing, right? The first value of a is 5, then 4, then 3, then 2, then 1. So my last values will be 1. So when I'm checking a is 1, when I get the last value is 1, then I will return 1. If I don't make it this 0 to 1, so what will happen? My result will come 0 only. So I will make it 1. And else I have to use this a multiply my this whatever a is coming, a multiply, and this recursive call with a minus 1. A minus 1. I will give a minus 1. So a minus 1, what it will do? 5 into factorial of 4. Next time 5 into 4 into factorial of 4 minus 1, 3. So this type of recursion is happening, right? Multiply of the values. So final, when you run this complete factorial, so you will get the value 120. So if you call this fact, so this is a way you think about it, like how to write the recursive function. Okay. So when I want to print factorial of, I say 5. Okay. So I'm going to print now. So my last value is coming 120. Okay. If I give 3, I will get 6. I will get 6. This is the factorial. Okay. So one Fibonacci series is there, right? Okay. Fibonacci series is like I say, what is the Fibonacci series? Fibonacci series start from 1, 1. So these are the two first element we know, 1, 1. And third element will come the sum of the first two element, last two element. Okay. So here is 2 will be the sum, then 3 will be the sum, then 5 will be the sum, then 8 will be the sum, then 13 will be the sum, then 21 will be the sum, 34 will be the sum, 55 is the sum, right? So this Fibonacci series summation, I want 10 number summation. So how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So last value, I should get this 55. Okay. So if I'm giving input is 10, I should get 55. If I'm giving n is 11, okay, so I should get it 89. Okay, I get it this. So my program here doing the Fibonacci series sum. Okay, so I define a function and it will be taking only one input value, and I'm doing the pattern matching here. It's a very useful like pattern matching. If case is 0, I will return 0. If case is 1, if my input is 0 or 1, I will not doing any Fibonacci, because 0, 1 is like 0 means no element. Okay, and 1 means only one element. So only 1 will be the value. And 0, if I say, the Fibonacci means 0. Okay. But when I say if it is not 0 or it is not 1, maybe 3, 4, 5 or 10 element, so then it will be doing here recursive. So what is a recursive? Case underscore means any number except these two. And I'm taking input and I'm just doing n minus 1, n minus 2. Suppose my number is 2. So 2 minus 1, Fibonacci 1, and 2 minus 2, 0. For 0, it will give the 0 result, but 2 minus 1, again, it will be case 1, it will give only 1. Okay. So we will get the 3 element, 1, 1, 2. For 2, we'll get 3 element, 1, 1, 2, and the sum will be the 2 plus 1, 3 plus 1, 4. So this function we will create, and we are doing the sum plus we are doing. Okay. So I'm defining this Fibonacci series function. Okay. And I'm calling so this 6 is coming here. Okay. So now if I say only 3 element, okay, it is this Fibonacci actually is not started 0, 1, it will start. 0 will be the starting element. 0, 1. Okay. 0, 1, 1, 1 plus 1, like this. So second element will be this 1 plus 1 will be 2. Okay. Because they are using 0. Okay. So now the 2 is coming. Okay. So this way, this is doing the sum of the Fibonacci series. Okay. And in the Scala, like functions like having a default value. Okay. So if you are not passing the parameters, suppose my function is taking 3 parameters. Okay. So I can set the default value in the function declaration. And if I'm not passing the value, it will take the default value. So in this first example, it will be doing the sum 70. Second one, it is doing 15 plus 0, 15. And the third one, I'm not passing any parameter. So it will be doing 0 plus 0, 0. Okay. So this is a default value concept, right? If you say like, okay, you have lesser number of parameters, like you are passing the value, but you want to keep it default for the other, you can set default. You can set the default for all. So whatever values you are setting, it will take it. So, okay, the first value will be going to the first parameter, second value will be going to the second parameter. So like this, it will be assigning the value. Okay. So there is a named parameter concept is there. This is an index, right? Because I'm not specifying this 15 is going to the first value and second will be going, this 2 is going to the second. It is by default is using index parameter. Okay. But in the Scala, there is a way like I can set it as a named parameter. So in that scenario, if you change the order also like A15, B2, and then you say B15, A2, you will be assigning to the same value, same name parameter, you will get the value. Okay. So here will not be used index. Okay. So index will be used when you are not passing as a name. Okay. So then it will be using the index. Otherwise, it will use name when you are specifying the name parameter while calling it. Okay. So this is the way to pass the. And the next thing is in Scala is a higher order function. So higher order function I already talked about that, like higher order function map, flat map, filter. So this higher order function is taking function as a parameter, or it can return a function as a parameter also. Okay. So here, if you see, this is my custom higher order function. So which function is a higher order function? Which is taking as a function as a parameter. Okay. So I define a one function. This is a normal function. Okay. This function is a normal function like multiply by 2. So whatever value come in this multiply by 2, it will be doing multiply of 2. Okay. But add 2 function, this is higher order function. So this add 2 function, no, multiply by 2 is taking a function as a parameter. Okay. So add 2 function is a normal function and multiply 2 is a higher order function. So it is taking, if you say multiply by 2, actually this is a function composition. This is not a higher order function actually. Actually, we have to pass it as a f and arrow sign, we have to pass it. Okay, this is the function composition. Composition means when your one function, like inner function is giving some output, that will be given input to the outer function. Okay, so this one, the two functions you created. This is function composition. Okay, not higher order function. Okay, so two functions are there. So here is a first add 2. So add 2 taking 10, 10 plus 2, 12, and this 12 is given input to the multiply 2, then it will become 24. Okay. So this is called function composition. Okay. Actually, I have pasted the same example for both. Okay. Okay, I copy. So higher order function is like I have function as a parameter, right? So here the multiply by 2, okay, multiply by 2, this is function. This function example is a higher order function because it is taking this multiply 2 as a parameter here. So how I'm calling it here in my higher order function, I'm calling as a function name. So first value I'm passing as an integer value, but second parameter is a function. Second parameter is a function. And this parameter is a function I'm specifying here that a function, it's a type is a function. And then I'm calling that function I'm calling here with this parameter. Okay. So when I define this higher order function, Yeah, I have to print it, because if I'm not printing, it will not come result. So whatever return value is coming, I have to print that return value. Ten to multiply of 2, 10 into 2, 20, and 20 into 25. Right. So that is 500. So first multiply by 2. Okay. So this one is a pass as a like a parameter 10. We are passing the 10 multiplied to 20, and then it will be calling the this multiply 2, and then it will be doing the other function it will call, and then it will use this 25 into 20, then it will give the result. Okay. So function composition. Okay, this I covered already. So lambda is an anonymous function. So two ways we can use lambda. Either we use a equal greater than sign, or we can use underscore wildcard character. So here I'm not specifying any function name. So it's an anonymous function. So the definition is same everywhere, either Python, Scala, Java, everywhere the function that this anonymous function is lambda is an anonymous function. And here, whatever variable I'm assigning, I'm using it right here. If you see result 1, I'm passing the 10, 10. So this 10 will be given input to each variable, and then I'm doing the sum. Okay. And here I'm making it more shorthand. So here just simply underscore means like one value. One underscore means one input value. One underscore means one input value. The first one is the first input value, and second one is a second input value. Okay. And I'm doing the sum of these two, and then I'm returning to the result. So this is anonymous function. One concept there in Scala is currying. So currying is suppose I don't have the enough parameter for my function. So one function is there add, and this function is taking 2 parameter. But right now I know only one value. I don't have the second value. The second value will come later. The second value will come later. So I will use add 10 and then give the underscore. So underscore is your continuation, and this continuation, like you will be giving this next value later, and the final result will be coming after giving the value. So first you are defining the function, and here you are not in a single round bracket. You have a separate round bracket because you are passing the parameters separately. You are not giving the parameter all together. But you can give all together, but separate bracket you will give. Okay, suppose you know both the values. So you can give both the values in a separate round bracket. But if you know one value, so you can give one value and then you give the continuation, and then further whatever the result is there, you can pass it to the second value. Then final result you will get it. So currying is basically taking a lesser number of parameters. Okay. And what is the missing parameters, you can give it to later and then get the final result. Okay. So that's the purpose of the currying. Okay. So this way we can call it. Okay, so I can define some function. Okay, so I want to because these variables already created. That is the reason it's giving error. Okay, now I run. So 10 plus 10, because I have both the values together, I'm getting the result immediately. But here I don't have the 3 immediately. But later on, like I'm just giving the value 3, I'm getting the final result is 13. Okay, so this way I can use the curry. Scala has the nested function. One function is having another function body. So that is called nested because this add function has the body of add 2. Okay, but in add 2, I'm calling inside the add. Okay, So when I'm passing the 10, 10, 10, so it will call the add function, and inside this add, it will call add2. So first it will be passing 10, add2, 10, 10. So this add2 will be doing 20. Again, add2 will call, and then we'll get the result 30. So this way we can use nested function. So nested function is similar to the recursive only. Okay. But here we know how many time of nesting is there. Okay. Because here nesting is fixed, right? Okay. Suppose I have a 4 parameter, 10, 10, 10. So how many times? So I know the nesting is a fixed number of time the nesting will happen. Okay. But in the recursive, I need to find the endpoint, right, where I have to come out from the recursive call. So I have to define that condition. So condition is needed. Here is no need of condition because automatically it will come out, because based on the number of parameters you are passing and how it will be utilized in your nested function. Okay. Scala also having the variable length of parameter. Sometimes I'm not sure like how many input values I'm giving. So those values I'm not sure like how many values can come. It may be a 2 values, 3 values. Okay. So one way is there, you can define the list. So list is a very ideal way because list is can accommodate any number of values. Okay. So that is very easy way. Like you can define args colon list type. Okay. List type you can define. And then you can do, so suppose the same thing you want to do with the list, you can do it. Okay. So I define the function. Okay. And this is using list type. List of integer. Okay, so suppose I'm saying I'm passing list of integer values, and simply I will be doing the sum. I will do each value of the list, right? I will do the sum. Okay, so this is the one way. Okay, and I will be calling this function and I pass the list. So I have a some list, this one AR. So this one I will call to my function at 7. Print. So I will print it. So this is example simple, right? I have the values in my list and I want to print it, but I want to pass it as a variable, not the list, because list means it can be variable. Okay, fine. But I want to use it as a variable, not the list. So in that case, I will use the type and then I will define the star. So in that case, when I'm defining int star means it can accommodate any number of values. Okay, there is no fixed number, but whatever number will come, it will assume as a list. It will assume that all the variables are as a part of list, and then it will do the sum. Okay, but here when I'm calling it, I have to pass as a integer values. It is saying pass as a integer. So suppose I'm passing 1, 3, 4, 5. So I'm passing 3 values. So it will do sum of 3 because I'm passing the 3 variable. Okay, but I can now I'm not changing my function body. I'm changing only the number of parameters. I'm changing the number of parameters. So my sum will automatically. But suppose the same thing if you are going to do with the variable, so you have to define the number of parameter, right? ARGS1, ARGS2, ARGS3 like this. But you are not sure, right? How many number of input parameters are there. So you have to define manually. So the other solution is like you can define the var arg. So var arg means whatever the type of values are there, you define the star and it will be used in that function. You can take each input value as a list values. You will be take input values as a list values and then you can do. Okay. Okay, so we take a 10-minute break and then I will do the next thing is classes. Okay, class concept. So this is little bigger. Okay, so what is a class and object? So function till we have completed. Okay, if has someone doubt, so can ask so far. Okay. Are you guys able to hear me?
Yes,
So,
yes, yes.
so command line is like you have to install Java. After once I install Java, so I'm able to open. Okay, I show again. So you need to say that you have to set the Scala home and bin path, and then you open the CMD. You can type Scala, so you can get the Scala prompt. So this is the interactive shell. So if I define where x equal to 10 and x plus 2, okay, in x, so I'm getting latest value, and I define well y equal to 12, and I try y equal to 23, is giving error. And suppose you want to define the function that, so I'm telling you how to write a code in the, because here you cannot write a complete code in a one shot, right? Because suppose you want to write a function. So there is a one way is there, you can use paste function. Paste, you can write paste. And then after you can write any code. The complete, even the complete object, class, you can copy paste it. Okay. Suppose I want to define a function that show taking some integer value and returning a string value. Then you are returning here print so whatever integer value you want to, this is a function end. Okay, so whatever x is coming and hello you are adding, but this will become a string, right? And now control D, your function is created. Now you use the function, so you are getting 10 hello. Okay, because this value has become now string because you added in some integer value with string. So now final result is a string, and that you are returning. Okay, or you can define the function directly here also, tab show, and you say integer colon string equal to braces, and then enter. It will be giving you the continuation mark. Okay, and then you can write a next statement, x plus 5, and then you can close and then enter. Your function is created. So now this function is overridden because you have used the same function. So when I call the show, so now which function will be executing? The other one, right? The other one. So now this is the result. Okay. So this is a way to write function. So even you can write a class object, complete object or class you can write. Okay, just take an example of suppose this example is there. So you write a complete main object. Okay. So you just paste. Okay, it will paste it. Okay, and then enter. Your object is created. Now you want to run this object, right? You have to run object because you instead of running the function, you will want to run this complete main object, right? So you will do main object dot main function and pass null. So you are getting the 30 is a result. Okay, so this way you can do. Another way is you can do paste. Okay, and when you finish, then you do control D and right click paste. Okay, and then control D. This is also, so that's the same thing. Either you can do directly paste on Scala, it will automatically take the continuation. But if you do like multiple objects, you can do. Okay, so multiple objects, like you can do one object after another object, right? Different objects are there. So like one is the main object, one is the main object one. Because you have a one main object and one is a main object one. These are two different. So you can copy paste these two in the colon paste and paste it. Okay, and then control D. The two main objects are created. One is a main object, one is a main object one, and then you can call by their main function. Okay, so but this Scala shell is only the session is there. If your this is if this session, if I close it, everything will be gone. Okay, so that's the reason I told the Scala session, right? The Scala shell is used for the testing. Like you want to test some logic and you want to write some function and test the logic, you can test on the Scala shell. On the interactive shell, you can test. Okay, so that's the purpose of the Scala shell. So you can testing you can do in the Scala shell, and then you can write a code in the editor. So you can use even Scala one. Eclipse also providing the Scala ID, one Scala IDE. Okay, when you download, this is the Eclipse version, Scala ID. Okay, so when you go this Scala ID, this is having a Scala plugin itself. Okay, so you can download it, and then you can, it is for Windows, Mac, Linux, all three different operating system, you can use it. So this is Scala ID, and IntelliJ is the one, and the other like you can use the command line, the Scala shell. Okay. So next thing is oops concept. Okay. So Scala object and classes. So little bit we gone through it, right? Object is a singleton, but here this object is related to class. So when I say object is related to class, means it's an instance of class, that object. Okay, and which is defining the properties and behavior of the class. So class is nothing but it's a blueprint, it's a prototype, and it is defining the two things. Okay, class is having the state and behaviors. So state, we call it variables and fields, and behaviors like functions, methods. So these are the behaviors. Behaviors means like something you want to do on your properties, anything you want to do, you can write the code in your behavior. Okay, like person is a class, so person has eyes, ear. So these are the states, but he's running, he's watching. Okay, so those are the actions. Okay, so this is the object oriented world, right? Everything is in the world is an object. Okay, an object having the two things, state and behavior. But some objects are only state are there, they don't do anything. Those are like in English something we call. So state and behavior, these are the two things, right? State is the properties, and behavior, we are doing some action on those states. Okay, so it's combined together in a single unit that is called class, and class is a blueprint. And we can say objects like instances, the collection of instances are called class, and those are the same type. Those are the same type. If I say animal is a class, so all animal instances will be the part of animal class. Okay, because they will not behave like any other type of class, because they have all having the same properties and behaviors. Okay, so that's the reason they are the part of the same one class. So classes have these components, like it could be one or it could be many, right? It could have a class, nested class, super class, block is there, constructor is there. So all are not mandatory. The basic thing is for any class is just class with property and function. Like at least we define these two things. Okay, because if I don't define the property, if we define only function, that will be no use. Okay, or I define the property, if I don't define the function, that will not be used, right? So if I want to use it properties, then I define the function as well. So here is a one example of class student. I'm defining the properties. Okay, but this class showing its default values, because I'm not defining any function, right? I'm not displaying any values of this class. I'm setting not the properties. I'm just simply creating a class with the default values. And when I'm just creating a instance of this class, I'm getting the default values. Okay, but I want to write some function, so I can define the function in the class. So here is another way is, rather than defining the values like here default value, I can use the primary constructor. So advantage of the primary constructor is, like when you are creating an instance, you can pass the values and you can initialize the value. So what is the use of constructor? So constructor is basically doing the initialization for your instance. Okay, every instance has its own value. Suppose I'm creating here two instances, one with student ID 100 and Martin, and another student I'm creating 101 and Martin 1. So these two instances are separate instances of the same class, but they have different values. So the values will not mix to each other. Okay, so every instance keep its own data, right? So if I'm going to create 100 instance of this class, so all 100 students having their own set of values, right? IDs and names, right? So class having the instance having its own proper values on data. Okay, so here I created a two student object, and both are, when I'm doing get record, I'm calling the same function, but whatever instance is current instance, that instance values will be coming. Okay, when I'm calling the get record on the student 1, so I will get the result of student 1. When I'm calling the get record function on the student 2, so functions we are calling on the instance. So instance is used to access the property and function of a class. Okay, so if I'm having a one class student and I want to call its function, so I have to create an instance and I can access the property using the function. Because these properties are the private properties, I cannot access sometime directly if I'm defining the private. But right now this is not private, this is no access modifier. I will tell about the access modifiers. So one is a private, one is a protected, and one is a no modifier. No modifier means when I'm not giving any specific access modifier, then it will be assumed as a no modifier. And no modifier can be accessed directly. You can access student1.id. You can access student1.id. So it will not complain. So here student1.id will be accessed because it's a no modifier. So when I create this, okay, what is my main object? So my student class, so here it is not able to recognize this because in the same class it will print. Okay, so I want to get it, I want to record, I want to get it through the, I set it, I have to call one get function. So get function is printing ID and name. So if I define where ID, so here it is. Okay, so this, so by default, this when we are using through the primary constructor, it will be going as a private type. Okay, so that is the reason we are not getting. Now I print it. So I'm able to access because it's a no modifier. I'm specifically specifying a no modifier. Okay, but when I'm saying here, when I'm passing as a parameter from the main, right, as a to class constructor, that will be going as a private, and private values you cannot access outside the class. Same class you can access, okay, but within outside the class you can't access. Okay, so it will give you the error. Okay, so this one, anonymous object. What is the anonymous object? I don't want to create this object. I don't want to create object instance I directly write this new student and get record. So I can copy here and paste it here, and I can directly call the function. Okay, so this way I can do. So I have some class. Okay, so some class I created. Now I created main object. Main object. Main null. So I'm getting some. So here this new arithmetic, I'm not assigning to some instance. I'm directly calling the method on the instance. So this is called anonymous object. So anonymous object is when you're not creating the object explicitly, instance explicitly, and then you are calling the function. Singleton already declared, I told about, like singleton is a object is a singleton, right? So singleton, some object is a singleton means it's a object. Okay, an object is having the main function. Okay, what is a companion class and companion objects? Companion class, companion object means when the object name and class both are in the same file and both are having the same name. That is called companion class and companion object. The class will be called companion class and object will be called companion object. Why they are companion to each other? Because both are having the same name. They can interchange to each other. Suppose some property you define in the, okay, here you can see this example. So here you define some private property of companion object you can access in the class. You can access in the class, or you define some property in the object you can access in the class, and you define some property in object you can access in the class. So it is interchangeable, right? So you can access this thing will happen only when you are using object name and class name both are same. That is the reason it is interchangeable, right? So you can access any property in object or any property in object you can access in the class. Okay, so you are keeping it the class name and the object both are same name. Okay, and then we can access from each other. So here what I'm doing here, I created a one companion. This is actually, if you see, this is the class, just defining the function. This is a class and defining the one private property and one function, and companion object is a object type. Okay, this object, and this object is having the main function. So how you are calling the function of this one? So you are creating a new object of this one and then calling. Suppose you want to access the property of this one, this str. How you are accessing? By creating the class instance of this class, and then you are calling the property. Okay, and here you, how you are calling this str1, you have an object and directly you can access in the class. Okay, so you can access. So I have already created the companion class, companion object. So companion object, companion class. So here, when I run this, so hello, this is a companion class, hello1 is coming. Hello1 is defined here, hello1. Okay, so first it is printing, when you main function call, first it will call this, and this hello is having the str1. str1 is a hello1. When you are calling this one, this println statement, second one, this println, so and this is a companion object and it is printing hello. So this hello is coming from the this private property of class. Okay, so this is interchangeable in companion class and companion object. Okay. Okay, Scala case classes, case object. So this is whatever we seen that pattern matching. So same case class coming again here. So case class is you are creating a class with the parameters. You are defining case class and case class name, and you can create an instance of the class and you can access the value. Okay, and you can use this case class for the pattern matching. So here you see you have three different case class 1, case class 2, and one is a case object. Okay, so you are saying 2 parameter and 1 parameter 1. When you are giving 2 parameter 1, so case class 1 is called. So here you are saying case class 1 and you are passing 2 parameter, and then you are printing these 2 parameters. Okay, so println, so whatever input is there, these are the 2 input is there in this case class 1. So you want to print these two. If you have one parameter, you are printing one. If you don't have anything, you are not printing anything. So you are passing with two parameter, one parameter, or no parameter. Okay. So based on the number of parameter and which class is this, then it is calling that particular case, it is calling. Okay, and then it is executing this println statement. Okay. So what is a constructor? Constructor is for initializing the value. So what is a default constructor? When your class doesn't have any constructor, so by default is a default constructor. So that constructor we don't need to define the empty constructor. That constructor will automatically call. Okay. So this constructor is not initializing anything because default constructor is generally at the time of creating instance it is called, but it is not initializing anything. Okay. So every class has the default constructor. But when you define the primary constructor, so primary constructor you define in the declaration of the class. So you define like this ID in name string. But the values is a private type. Okay, this constructor. So you have a show detail function which is using the value of this primary constructor values is using. So when you are passing the primary constructor values, it will be assigned the values, and then show detail function will display the value. Okay, so this is the primary constructor. Auxiliary constructor is a secondary constructor. So secondary constructor we use with the this keyword is used for the secondary constructor. Suppose you are passing the three parameters, student class, three parameter, but your primary constructor is taking two parameter, first two parameter. The third parameter is set through the secondary constructor. So secondary constructor is calling the primary constructor. Same concept in the Java, like constructor overloading, right? You have secondary constructor is calling the primary constructor first. So the first two values will be set by the primary constructor, and the third value will be set by the secondary constructor, this dot age equal to age. So when you do three values, so you will print these three values. But when you are not giving this third value, so you will get the 0 value, that is a default value. Okay. So when you create this class, object, okay, first I have to, class is not created. Now object. Now I run this. I'm getting this. Okay, so if I don't pass this 20 and then I run, so my secondary constructor will set 0. So 0 will set because I'm not passing, but I'm not getting any error. Okay. So if you are not using the secondary constructor, so then the other way is like you have to set it the age also the primary constructor. But in that scenario, you have to give always age value. Otherwise, it will give you the error. Okay. So secondary constructor generally used to define some additional values, right? You want to initialize, which is not required initially. Okay. So you can initialize first with the primary constructor values, and if you have you have the other values other than the primary constructor values, so you can pass it as a like secondary constructor, you can keep it, and that can initialize the additional values. Constructor overloading. So constructor, this is constructor overloading only, right? You have primary constructor and secondary constructor, then you are doing, when you pass the first one parameter, so primary constructor will be used. When you are using two values, then it will be using this secondary constructor, and secondary constructor will call primary constructor. Okay, that is the reason we have this dot id. If you seen here we have this dot ID and name, right? So we can use primary constructor call from the secondary constructor. Okay, so we can have multiple options. So multiple this can be there. Okay, so with the 2 parameter, 3 parameter, 4 parameters, as many as number of secondary constructor you want to create, you can do. Okay, Scala having the method overloading. So method overloading and overriding, two concepts are there. Overloading is a concept of polymorphism. This is polymorphism. So in the object-oriented programming, the polymorphism is like one interface, many form. One interface, many form. So I want to keep the function name same, but I want different logic. I want to write different logic. Okay, so I can use function overloading. Function overloading happen in the same class when the function name is same, but the number of parameter and type of parameters should mismatch, either one of these two. If you are making it number of parameter different, then function overloading will take place, or you should have the type of parameter. Suppose both are the number of parameters are 2, but in that case you have to make it type of the parameters you need to change. Int and float like this. So two add functions, both are add, but one is doing the 2 values sum and one is doing the 3 values sum. So in the main function you are defining which function you are going to call, because based on the number of parameter it will call that add function. Okay, but overloading happen in the same class. Okay, that's called overloading. So when I, because it's a very common concept in Java also there, the overloading and overriding. When I call main object dot main null, so I'm getting 20, 30. Okay, so this is my overloading. So you can make it data type change. Suppose your number of parameters are same. In that case, you can go for data type change. Any one of the things you can change, either data type or number of parameters. So this is for two different data types. Okay, Scala, this is for use secondary constructor, right? So we can use auxiliary constructor. Using the this we can define. So Scala constructor calling by using the this keyword. So this keyword is used to call the primary constructor. Okay. So next concept in the object-oriented programming is inheritance. So inheritance, like when we have parent and the child class is inheriting the properties and behavior from the parent class. So that concept is called inheritance. So inheritance, we use the extends keyword. It is in the Java, Scala, Python. Okay. So it's extend, and thus we write a super class name. So I say I have one class employee and one class programmer, and programmer is extending the employee. So this salary will be inherited here. So whatever salary you defined here, the same salary will come. Okay. So what is the use of inheritance? I don't need to write reuse. I can reuse the code, right? Whatever in my parent class. So everything will be inherited. But I want to do some modification. I say, instead of this programmer, like I have another one more class is there, architect. So his salary I want to change. So I can change his salary in the child class. I can override it. So I have to use override keyword. Okay. I will tell about that. Types of inheritance. There are the different types of inheritance, means single inheritance, multi-level, multiple, and hybrid. Okay. Single means one class parent and one child. That's it. That is single. Multi-level is A is a one class, B is inheriting from A, and C is inheriting from the B. So that is multi-level. Multiple is like two classes, right? Okay, I say I'm extending. Okay, but in case of multiple is directly not supported, so we have to use trait. Okay, or in the Java we have to use interfaces like multiple. Okay, hybrid is multi-level and multiple together. That is called hybrid. Okay, so these are the concept are there. So one class A is having the salary, second class is having the salary, different salary, and class C is having both the salaries, because A is inheriting B, B is inherited by the C. So C will have both. This is called multi-level. Okay. So Scala method overriding is in the parent child only. So what is the use of overriding? Suppose I define some vehicle class and vehicle class is saying run function. So vehicle doesn't have any concrete name, right? Like, okay, vehicle means it could be any vehicle, right? So I want to define some particular vehicle, then I can define the run function. But I need to define some function in my parent class. So I'm just saying vehicle is running. But when I'm overriding, when I'm extending this vehicle in bike, so I'm saying bike is running. When I'm overriding in the some car, okay, suppose I create a car here, so I say car is running. Okay, so here I'm just creating a multiple classes, extending the parent class and overriding the function. So this is called overriding. Okay, so the parent class function is overridden in the child. So what is the condition for overriding? The first condition is the class should be extended. Second condition is the function name and body, the function name declaration should be the same. This function name declaration should be same. If it is not taking any parameter, so this will not be taking any parameter. If it is taking parameter, it will be taking parameter. So signature of the function will not change. And the last one is we have to use override keyword. Okay. So override keyword is making sure, right, this function you are overriding. If you don't this, then override keyword, then it will give the error. Okay, let's try this one. So here bike is a car. And here you are saying, suppose you create a car instance. So this is called runtime polymorphism. Overriding is a runtime polymorphism. There you are calling the function at the runtime, and whatever the object you are assigning, whatever the child class object you are assigning, that function will be called. Okay, so suppose you are saying car instance, so car run function will call. When you are calling the bike, so bike run function will call. Okay, so that is like child object you are assigning to the parent reference. Okay, when you call, when you create all these classes and object, okay, now I call the main object dot main null. So first I'm calling the bike is running. When I'm calling the car is running. Okay, so this is overriding. Overriding is in the parent child. Second one is overriding is using the same signature of the function, right? Okay, whatever the function signature in the parent. And the third one is overriding using the override keyword. Okay, another example you can see here, like some bank, and bank is having rate of interest. So every bank has its own rate of interest. So that's the reason they are defining rate of interest 0. Because whoever bank is extending this bank, they will give their own rate of interest. So this bank, this bank, this bank, they are giving their own rate of interest. So when I'm printing, when I'm creating an instance of the class and call the rate of interest function, so I will get the implementation of the class, whoever class is implemented. Okay. So field overriding also there, method overriding is there, field overriding is there. Field overriding is like, suppose I have a vehicle class, I have some speed variable, and I just defining simple var speed, I'm changing the value. I'm not using any override keyword. So you will see some error when I run this. So I'm getting an error here. The speed, the override modifier is required. The class vehicle of type, okay, the override modifier is required. So I have to define the override keyword, then only I can change. So suppose I say vehicle, so car is having different speed because every vehicle has its own speed limit, right? So I'm saying its speed limit is 100, max speed limit, okay, 100. But car is having more than 100. Okay, aeroplane has more than some particular limit. Okay, so I can define that value and I can override it. Okay, so I will get it the value which is overridden. That value I will get it. So I'm calling the bike one. So bike one, I will get it this. If I don't override it, if I don't override, I will get the parent one. If I don't override and I will run it, I will get the parent class one. I will get the parent one 60. Okay, so I'm not keep changing. Okay. So field overriding, okay, field overriding is possible. Okay. And one more thing is variable speed cannot override a mutable variable. So we should have always the val type. That is the one more thing also we should remember. So there are the two types are there, var and val. Okay, so they are saying variable speed cannot override a mutable variable. So this variable should be val type, then it will override, otherwise it will not override. So here is a restriction. When you define any variable, it should be a type of val only. Okay. Okay, final. What is the final? Final is like it could be a final class, final method, and final variable. Okay. So when you define a final variable, the final variable just simply you define a final keyword, and the variable will become final. It can be constant. It will behave like a constant. So you cannot change the value. So when even I'm doing the override, I'm not able to do because my variable is a final. Okay. So when I'm defining any variable is final, I cannot change. So that is the final use of the final variable. What is a final method? Final method is like I have a parent, some function show, and I'm defining as a final. In bike class, I'm trying to override it. So it is not allowing me to override it. So what is the use of final? Generally, why we go for final? So final is like, suppose I don't want to allow someone to modify my method. So I will write it final. Okay. Suppose you don't want to allow any function of the class override, then you can use final class. When you are writing a final class means everything will become automatically final. When you write final class vehicle and you are trying to extend, it will give you the error. Okay, you see. So final class method automatically become final, even you don't specify. Okay, so here you are getting the error, illegal inheritance because from the final class vehicle. Okay, so you cannot do. But if you are defining the class vehicle and define the one final function, so only this function is final. But if I say one more function is there in this class, but that function is not final, I say that function is a show1, and now I override that function, show1. So this function, so the advantage of keeping it only final method instead of the class, right? We can allow some function to override or some function we don't allow to override. Okay, so I say non-final method. The non-final method is can be overridden because this is no final, but this is the final. So when I run this, okay, I print show1 also. So show will give the error, right? Because show I cannot do. The show is a final. So this will give the error. Okay, let's see first what error comes. So I run this. Here itself, I'm giving error. I'm getting the error in the defining itself. Okay, in defining, when you're creating this class itself, you are getting error. This class is not a problem because this class is just having the function. So this class will not give any issue. This class is fine. But when you are trying this class where you are extending the vehicle, so in this class, you will get the problem because this class you are extending vehicle and you are defining the show, which is a final. Okay, so either you remove this function, or you just not use it, or you just don't use this function. So you comment this /star /. Okay, now I'm able to create. But this show function I cannot use, show1. Okay, I have done wrong one. This is the one, show. star slash. Okay, so show, I'm not using show one. Okay, now main of only non-final will be giving output, non-finals. Okay, so this is the, and when you are making a class final, then you can't extend any function. You can't like override any function. So what is the abstract class? So abstract class is the class which is having the abstract and non-abstract method both. Okay. So generally we define any function in the abstract class, by default automatically it will become abstract if I'm not defining the body. But if I'm defining the body also, suppose I say another function is there, def run one, right? This function has the body. So when I'm extending any class from this abstract class, I have to override this function, because this function is already body is there, it will be inherited. But this function is no body, it's an abstract method, it should be defined in the child class, or I should make it this class also abstract if I don't give the body of this one. Okay, suppose I'm just overriding run one. Okay, so I make it this class also abstract. So this is the rule of abstract class. You have to either define the body of abstract class in the child class, or you make it the class abstract. Okay, so when I'm just creating a class with the, sorry, not run one. So abstract function should be overridden in the child class, otherwise we have to make it the class abstract. Okay, so what is the use of the abstract class? Abstract class is having partial and non-partial. Suppose I don't have implementation now, but in the future implementation will come. So if I say ordinary cars are there, they don't have security system, but future they will implement it. So they can make it their car as a abstract class. They will give the basic property of car, because car need steering, vehicle, steering, wheels, everything. These things are common things for any car. But when I say security system, it is possible, like there is no security system in the ordinary car, but in the costly car, right, in the expensive car, the security system will come. So later on, they will add that feature based on the price. Okay, so this abstract class initially have that security system method will be abstract like this, that security system empty. Okay, but when I'm just implementing it, I will make it the body depending on the car type, and there are many other criteria. Okay, so that way we can use the abstract class. Abstract class is the partial implementation when we are not sure about the implementation now, but we can use it in the future. So those abstract implementation we can define. So what is the difference between the in Java abstract class and interface? So interface in Java only define the abstract method. There is no implementation. But in the Java 8, they have given the default method use cases. Okay. But in the Scala, there is no interface concept. So that thing is covered by the trait in Scala. Okay, so simple here. And one more thing is abstract class object you can't create. We can't create this class object, because it's no point to create object of this class and call function. The class which is extending the abstract class, you can create object of that class. Like here you are creating hero. So this class object you are creating. So abstract class object cannot be created. That's also one more important thing. You cannot create an object of an abstract class. Okay. So when you run this, like you have defined some abstract function, and that abstract function is overridden in this child class, and this class object you are creating, and then this class, then you are creating the instance of the abstract class and using it. Okay, so here main object. So you are getting the abstract class implementation. Okay. So abstract class can have also constructor, variable, abstract method, everything, non-abstract method. So this is a non-abstract method is there, define performance. Okay. So in the child class, you can define the abstract class implementation. That is important because otherwise you have to make it this class also abstract. And then you can call abstract and non-abstract method both. Okay, because non-abstract method is coming from the parent class. So this implementation performance is coming itself here, right? Because you are calling from the parent to child. Okay. If you are not implementing abstract method, what will happen? This is the scenario which I was talking about. Like you have an abstract class, define run function, and you are extending this abstract class, but you are not implementing. So it will give you the error. Class hero needs to be abstract. Either you make it abstract or implement this run function. Okay. So to avoid this problem, either you must implement all the abstract method of the abstract class or make your class abstract too. Okay. Next thing is trait. Okay. So trait is like an interface with the partial implementation. So in Java, interface only contain abstract function, not implementation. But in the Scala, trait is having partial implementation or like we can implementation or non-implementation, both we can do. Okay. So suppose I define one trait printable, and this is only abstract function, no concrete function. When I'm extending this trait, when one trait is there, you can directly extend. But when you have two traits, so one trait you have to use extend and another trait you have to use with clause. So what you have to do, I want to use this trait function in my class, so I'm overriding it. So this is no implementation here. I'm implementing here, and I'm just printing this print function. So I will get the implemented version. Okay, it's the same thing like abstract class we do, right? The only difference is here trait like we are getting non-implementation and implemented function. Okay, and two traits we can use in the same class, but abstract class we cannot extend. Two abstract class we cannot extend in a one class. Okay, so when I defining so I'm getting this hello, whatever is coming from this trait. So I have another trait is there, printable trait, which has the print. So I'm just doing here the must be declared as an abstract class. Okay. So abstract class can also, so suppose I'm not printing this trait math, I'm extending this trait, but I'm not doing any implementation. So this is the same rule of abstract class. Okay. If you are extending the trait, but you are not implementing the method, so you have to make it abstract. That class you have to make it abstract. Okay. And you have multiple traits are there. Okay, so here we can see multiple inheritance. Okay, so two traits are there. So one trait I'm extending, another trait I'm using with clause. So both the traits you are implementing in this class and you are calling both the functions. So you will get the output. So here is a multiple inheritance. You can see like two traits can be used in the same class by use extending keyword and by using the with keyword. Okay. Okay, Scala traits having abstract and non-abstract method. So that we already seen. So suppose you have a one trait, with abstract function and one is a non-abstract function. So when you are extending trait, okay, so whatever is non-abstract function that will automatically come, right? Because it is already defined here in the trait. But whatever is non-abstract function, abstract function that you have to override. Okay, so that we have overridden. Okay, and then we can get. So Scala have trait mixing, right? You can have suppose one trait and one abstract class. This combination is there. So far we have seen all are the trait type, only trait. But now you have a scenario, you have a one trait and one abstract class. And trait is having also abstract function and abstract class also having the abstract function. So when you are extending, so which will give the more preference? Abstract class will get the more preference. So here you will get the error. Okay, when you run this, you will get the error because you are extending first trait and then extending the abstract class. Okay, so you will get the error. Here you are getting the error, print A4. So it is saying class print A4 need to be trait to be mixed in. So you should do the reverse order, extend abstract class and with trait. Okay, then it will work. So if you have like this trait and abstract class, so first you are doing abstract class and then trait. So abstract class will be first and the trait will be second. Okay, so order precedence will be the abstract class will be first. So when you run this, okay. So it is not giving any error. Object. So now it's printing fine. The first one is a trait one is giving, and second one is a, so print is a trait, right? So whatever you print first, that will come first. But here the order is important, which you are extending, which you are using with. Okay, so this is the example. This is the correct example. So you have to. And what is a scala modifier? So scala modifier is a 3 are there: no modifier, protected, and private. Okay, so private is, these are the accessibility. These are the accessibility. So no modifier can be accessed within a package, same package, class. Okay, all are yes. Okay, protected can be outside the package or same package. It will not be accessible. Protected means generally it is in the parent and child class we use, right? Some variable we define and I can use it only in the child, whether it's in the same package or it's a different package. So I cannot use in the other classes. I can use only in the child class. So that is called protected. And private is always accessible within a class. Even you cannot access subclass or outside class, outside package, nowhere you can access, only you can access. But private can be accessible in the companion. That example I showed you. So private can be accessible within the companion, and private can be accessible within a class, same class, it can be accessible. Okay, so suppose one class is there and this is a private variable. When I'm trying this private variable like this access, I cannot access, but when I'm making it the no modifier, so it is allowed. Okay, so when I access this, I get the error because I'm trying to access. It's a compilation error coming, even I'm not able to run program. So I'm able to get the error at the compile time. Okay, so here this p dot a, you cannot set the value, but when you remove this, now it's a no modifier. So no modifier, I can set it. Okay, I can run main object, main null. So I can set it the value 12 and I can get it. So here, this is example of private and the protected is, suppose I'm explicitly saying this variable is a protected. So protected I can access in the subclass only. So in subclass, automatically it is inherited. We already know any property is inherited. Okay, so protected will be inherited. Even the public also, no modifier will be also inherited. That's a common thing because inheritance means you can inherit it, the values from the parent to child. But protected is only accessible immediate subclass. Okay, if you say, if it is a no modifier, if you define access example 1, then subclass, and another class is subclass. Okay, so you have a 3 level of class. So this a variable, if it is no modifier, it can go up to any level of down, but protected will go to immediate level. Okay, just try that. Okay, suppose I create another class. Okay, let's see this example, and I'm extending this class. Okay, and I say subclass 1, and I want to access I'm accessing here A, I'm accessing here A. Okay, let's see first what it says. I'm getting the error. It is saying use override keyword. To override keyword you can do. Okay, overriding method, method display need override modifier. Okay, first it is saying you use override. Which one is giving error? Okay, let's see first. This one we do. Parent and child. So override is no meaning here because I'm using a protect. Right? So it is directly accessible. Okay, it is directly accessible. It is not because this method is not here, right? It is this class function, but this display I'm overriding here. So here is override is needed. So protected is you are using immediate subclass. Okay. Suppose I'm using okay subclass 1, but it is protected. Okay, protected, I can use it with the override. Okay, if I don't do this, because already this method is use this A. So that's the reason if I'm using override here, it will be allowed. Even the protected variable is there. So I have to use override keyword. So if my this function has used A, so if I define A here, if I'm just doing A equal to 12, I'm overriding the value. Okay, and here can you see here this one is not this A equal to 12. A equal to I think it's allowed. So it can be allowed, right? But it should be a subclasses. Outside the class, you cannot access the protected. So you can change it any protected variable. So outside the class, you can't access. So no modifier is accessible anywhere. Okay, you can access in the same class, or you want to directly access in the outside the class. Any class you can access. Okay, so this is all about this is the object oriented concept. Okay, so next thing which is left in the Scala, that is collections, exception handling, and file handling. Okay, these three things file handling. Okay, I'll cover it. This collection is a little bigger part. Okay, exception handling and file handling is not that much big, but collection is big. So all you can go through the tutorial point. I'll share this text files so you can do practice with this, but I copied from the T point. T point is color. Okay, anyone has any question, then ping to me. Yeah, thank you. I'll share the recording. Yeah, I'll share the recording link. Thank you.